All right, so today, lesson 99, inverse variation. We've talked in the past about direct variation. we said that y equals k over x. We have a constant. And I told you, like, maybe if you're babysitting and you get $10 an hour, that's your constant, okay? So the money you make, if you work 1 hour, you'd get $10. If you work 2 hours, you get $20, 3 hours, 30, and so on. All right, so the constant's the same. The amount you make depends on the time that you work. If you plotted it, the graph would be a line. It would go through the origin, and that's what we remember about direct variation. And there's other types of problems you can do, driving distances and so on. Well, today we're going to talk about inverse variation, where y equals k times x. And in this situation, as one variable increases, the other decreases. So this will not be a linear function. It won't be a graph, it's a line. And it won't go through 0, 0. So some example may be that maybe we have something like this. If there are, let me think a minute. If there's one worker, it takes 20 hours, okay? If there are 2 workers, it takes 10 hours, okay? If there are 4 workers, it takes 5 hours, all right? So you get the idea? And so x and y are going to be a constant here, okay? The more workers, the less time. Does that make sense? All right. So xy will be, the product will be constant. All right, so let's look at the first example. And again, I would suggest that you read in the book, lesson 99. The important things are there if I haven't presented it as well as the book. Let's look at this first example. And it says that Trin traveled 120 miles to visit his friend. All right, if he averages 60 miles per hour, the trip takes 2 hours, okay? So what is the quantity that remains constant in this problem, okay? The thing that's remaining constant is the distance, right? 120 miles. And our x times y has to be this constant, okay? So it says then, fill in the chart with other possible rate and time combinations. So if he's going a lot slower, or she, I'm not even sure who Trin is. Oh, he, okay. So if he's going slower at 40, and it's got to equal 120, how long would this have taken? 3 hours, right? If he goes even slower, 30 miles per hour, it would take 4 hours, right? If he's going so slow, 20 miles per hour, I'd go out of my mind driving 20 miles per hour. This would be 6 hours, right? Because the xy has to be constant. So it's an inverse variation. As one decreases, the other increases, or vice versa, okay? They're not both increasing. All right, so let's look at example 2. It says robots are programmed to assemble widgets on an assembly line. The number of robots working, N, and the amount of time, T, it takes to fix a fixed number of widgets are inversely proportional. If it takes 10 robots 8 hours, how long will it take 20 robots? Okay, so more robots should be less time, right? This constant, NT, needs to be 80. So 20 times what will be 80? 20 times 4. And that's reasonable. More robots, less time. It's inversely proportional. And if you look at these graphs, if I plotted these, and they've plotted one on page 660, the graphs are not linear. They do this deal. Okay? So, let's look then at the practice. I'd like you to do A through F. A through F. So pause, do those, and then come back, and we'll go over them. Right, so what you're supposed to do here is determine if these are direct or inverse. So if we have y over x equals k, that is a direct variation, right? If we multiply this, we get y equals kx. That is direct variation. If I switched it around, right, multiplied by x. This one, however, is inverse variation, x times y. The products are constant, okay? This is linear, so it's direct. This is inverse. All right, in this one, my x times y is 6, 6, 6. So this one is inverse, right? The products are constant. Here, the products are not the same every time. This is 3, this is 4. So no, this one, we don't know for sure that it's direct, but it's not, it is not inverse. All right, and down here, it said that there were 3 people working at an equal rate, 5 hours to complete the job. So how long would it take 5 people to do the job? So 3 by 5 is 15. So this product has to be constant. So 5 times what is 15? Obviously 3, if these are inversely proportional. All right, that concludes 99. So you are ready to go, and we'll see you soon for lesson 100.